Do subscribe to our channel and press the bell icon for further updates. Hello everyone. This is a session about binomial distribution. In the previous session we have studied Bernoulli distribution, and this is a continuation of Bernoulli distribution with the same experiments conducting many times. Let's see some of the things about binomial distribution. First of all, it is proposed by a statistician called James Bernoulli, and this is the finest example of discrete probability distribution. Now let's see the definition of a binomial distribution. If x is a discrete random variable with probability mass function PMF, P of x is equal to NCx, P to the power x and Q to the power n minus x, where x varies between 0 to n in a discrete manner, and P probability varies between 0 and 1, and Q equals 1 minus P. Then x is called binomial variate and the distribution of x is called binomial distribution. After seeing the definition of binomial distribution, now we shall see some of the examples of binomial distribution. The very first example, the number of heads obtained in 4 tosses of a coin. See, remember, if tossing of a coin is one experiment, it is having two results, either you may get head or tail. Here the same experiment is repeated for multiple times in 4 times. Then hence it is called an example for binomial distribution. Similarly, the number of male children in a family of 2 children. When a new baby is born in a family, either it may be a male or a female. Then this particular family is having 2 children. That means an experiment with 2 results which is conducted for many times. An example for binomial distribution. Third one, number of bombs hitting a target among 3 bombs which are aimed at it. When 3 bombs are aimed at it, or when in particular any bomb is aimed at a particular bridge, there may be either a chance of hitting the bridge or not hitting the bridge. Here in this case, the same experiment is repeated using 3 bombs, then multiple times. Again an example for binomial distribution. Number 4, number of defective articles in a random sample of 6 articles drawn from a manufacturing lot. You may observe whenever a manufacturing process is happening, there may be either a defective article chance of production or a non-defective article chance of production. Here in this particular case, if those two are the 2 results of the experiment, then that experiment is repeating for 6 times. Number 5, number of seeds germinating among 10 seeds which were sown. So whenever a seed is sown into a geographical area, there is a chance either it may germinate or not germinate. Again in this experiment, it is having 2 options. One is germination or not germination. The same experiment is conducting using 10 seeds. So all the examples are clear that each and every experiment is having only 2 results, getting head or getting a male child, hitting the bridge, or getting a defective article, or germination of seeds. All these are one result of 2 options what we can have, and the same experiments are repeating for multiple times. So these are the examples or the distributions where you can observe binomial distribution. Now we will see the features of binomial distribution. The first one, n and p are the parameters of binomial distribution. Here you can observe that there are 2 parameters for a binomial distribution. One is n, the number of repetitions of the experiment, and p is the probability of the experiment. And the range of variable x. Here x varies between 0 to n with a discrete manner, like taking the values 0, 1, 2 up to the value of n. It is a range of binomial distribution. And PMF of binomial distribution is P of x is equal to NCx into P to the power x into Q to the power n minus x, where x varies between 0 to n having a discrete values, and P varies between 0 to 1, and Q is equal to 1 minus B. The fourth feature is, for a binomial distribution, mean is equal to n into P, variance is n into P into Q, and standard deviation is square root of n into P into Q. The fifth feature of a binomial distribution is about mean and mode. Mean and mode are equal if n and p, that is n into p, is an integer. The sixth one is if p is equal to 1 by 2, which is also equal to q. That means when p and q both are equal, equals 1 by 2, then binomial distribution is symmetrical about p is equal to 1 by 2 or q is equal to 1 by 2. If p is less than 1 by 2, then it automatically means that q is more than 1 by 2, then binomial distribution is positively skewed. If p is more than 1 by 2 or q is less than 1 by 2, then binomial distribution is negatively skewed distribution. Is about binomial distribution. The binomial distribution tends to Poisson distribution when n tends to infinity and p tends to probability 0 and n into p is equal to lambda, a constant. This is the most important and limiting factor for a binomial distribution, where it says the limiting factor of binomial distribution. And the last feature is binomial distribution tends to normal distribution when n tends to infinity and p and q are almost equal. These two are very much important points or features of binomial distributions, because with these two connects to the next distributions of Poisson distribution and normal distribution.
Do subscribe to our channel and press the bell icon for further updates.